QuickSort Algorithm. Principle. First, we select a random key element from the list L that we want to sort. This key element is also called a pivot. Next, we create two lists L1 and L2 that respectively contain elements smaller and larger than the key. So L1 contains all elements from the list minus the key that are smaller than the key, and L2 contains the rest. Next, we recursively sort L1 and L2 with the same algorithm. Then we concatenate L1, the key, and L2. Example, on the top we have an unsorted array. First we pick a pivot. Here we've picked the last element, which is 5, and it's in the middle. So all elements in this array that are smaller than 5 go to L1 right here. So 4 goes here, 3 goes here, 7 goes to L2, 9 goes to L2, 8 goes to L2. Second iteration, the list 1 and list 2 are also quicksorted. So on the left side, the number 3 here becomes the pivot. And we see that 4 is bigger, so it goes to the list on the right side of it. Nothing is smaller, so it's an empty list. On the right side, number 8 becomes the pivot. So 7 is smaller, goes to the left side, 9 is bigger, goes to the right side. And we see that this is the last step of the iteration. So now we get the values back. So here we have a list of 3 and 4. On the right side we have a list of 7, 8, 9. And the final step on the bottom consists of concatenating these lists we have. So this list, 3, 4, then 5, which was the original pivot, and then the last list. Implementation. On the left side we have a quicksort coded in Python, and on the right side we have a quicksort coded in JavaScript. First, let's see the Python example. The first thing we'll do is implement the stop conditions. So if the length of the input list is less than or equal to 1, we return the list. Next, we create two empty lists, list 1 and list 2. Then we create a pivot element and also remove it from the original list. The pop function removes the last element from the list. Next, for each element in the list, if the element is smaller than the key, we append it to the list 1. Else we append it to the list 2. And finally, we return the quicksorted list 1 plus the key plus the quicksorted version of list 2. So on the right side we have the same example but written in JavaScript. First we check the length, then we create two empty arrays, then we pick a key with the splice function, then for each element of the list minus the key, if the element is smaller than the key, we push it to the list 1, else we push it to the list 2. And finally, we return an array of quicksorted list 1, the key, and the quicksorted list 2. Complexity. Let's see and be the number of comparisons to sort a list of length n. In the worst case scenario, which happens if we pick a key which is an extremal, meaning it's a minimum or a maximum, the complexity is a big O of n squared. In the best case scenario, which happens when the key we pick is a median, the complexity is a big O of n log n. The average complexity is a big O of n log n. If you need a proof, you can find one on Wikipedia. And that's it. Congratulations on learning the QuickSort algorithm. Thanks for watching and until next time.